Bucket sort. Bucket sort is an algorithm used to sort a collection of elements, provided we know the range in which these elements will occur. Let's see what the steps taken by bucket sort are using an example. So I'm going to consider a sequence of tuples. So I'm going to have, say, a few elements like this, a pair of elements. Let's say that these tuples are going to be part of a linked list. So it's going to be in this sequence. So each will point to its successor. So this is going to be my sequence of node tuples. A tuple is nothing but a pair of elements stored together. Now I want to sort these elements based on the number given in the tuples. So what will I do? I know for a fact that these numbers are going to be in the range 0 to 9. This is an information given to me before I start sorting. So we know that the range of the numbers is going to be from 0 to 9. This is an information we will receive. So the first thing I'm going to do is I'm going to create an empty array with indexes 0 to 9. So I'm going to create this empty array. And now I will have to make the indexes 0 to 9. This is going to be my array. Now I am going to traverse the initial list one by one. First I will look at 7D. Now, since the number here is 7, I am going to create a linked list at position 7 pointing to the node 7D. Now I will go to 1C. Since the number is 1, I will create a linked list at position index equal to 1 pointing to the node 1C. Now I will go to 3A. At position 3 I will start the linked list with element 3A. Then I will go to 7G. I will go to index 7. I will see that there is already a linked list formed. I will add it to the end of the linked list. 7G. Now I will go to 3B. I'll go to index 3. Add it to the end of the linked list starting at index 3. As you can see, when we create an array of range 0 to 9, we are going to create an array of linked lists. In the beginning, all of them are going to equal to null. We will traverse the initial list and we will insert that node to the index of the numeric value stored in the tuple. So if it's 7D, we will store it at index number 7. If it is 1C, we will start our linked list at 1C. If it's 3A, we will add it to the linked list at index 3. So this is how the first phase of bucket sort is going to happen. We are going to create this array of linked lists. Now, once we have created this array, we are going to traverse this secondary array, and every element which we encounter, we are going to add it to our new linked list. So I'm going to start at index 0. 0 is null. So I won't add it to my linked list. There's nothing to add. Then I will go to 1. 1 has the linked list 1C. Then I'll go to 2. 2 doesn't have anything to add. Then I'll go to 3. 3 has the linked list 3A, 3B. So this will be added to the linked list. So 3A, 3B is going to be added. Then I'll go to 4, nothing there. 5, nothing there. 6, nothing there. Then I'll go to 7. What should I add to my linked list? 7D, 7G. 7D, 7G. With this, I would have sorted my initial list and arrived at this new list. Now, this bucket sort is called a stable sort. Why is it called the stable sort? Because when you have a series of tuples and you have two tuples of the same key, that is, we have both of these having 7 here. So we have two tuples having the same key with which we are sorting. In that case, the tuple which we encounter first in the original list will remain the tuple we encounter first in the secondary list. So 7D comes before 7G. 7 and 7 are both the numeric values of the tuple. Now when we are sorting it, we are not going to change this position. D will come before G in the initial list, and so D will come before G in the final list as well. Over here, A comes before B in the initial list, and so in the sorted list, A will still come before B, even though the number with which we are performing our sort is equal. So what does this mean? If there is more than one tuple of the same key, the initial order of the tuples is retained. That's why we call it a stable sort. Now let's take a look at the pseudo code we can write for bucket sort. So I'm going to create an algorithm called bucket sort. As input, it's going to take some sequence S, it's going to take a range N, and it's going to take a bucket array B. So S is the sequence, N is the range, B is going to be the bucket array. So now what must we do? We need to start storing the elements which are part of the sequence into our bucket array. So while the sequence is not empty, what I will do is, first I will take out an element from the sequence. So I'm going to take out the element from the sequence. So S dot remove first. And what will I get when I remove this object from the sequence? I'm going to be returned some object which is going to have a key, which is going to be our number, and it's going to have some element E. So I'm going to get a key element pair from removing from the array, or removing from the initial list. Once I have this key element pair, what I'll want to do is B, which is our bucket array. So in the bucket array at index equal to the key, I want to add this object. So to this index, I will want to add to the end this object, which is a key element pair. So what did I just do? I will remove this from the list. Now my key is 7, my element is D. At the index of the key, so at index 7, to the linked list there, I am going to add to the end 7D. So that is what we are doing here. We will keep removing from the initial list until the list is empty. So while the list is not empty, I want to add from the initial list into the bucket array. Let's call this whole thing phase number 1. Now let's go to phase 2 of bucket sort, which is this part, which we are taking out from the bucket array and inserting into a linked list. So now we have to traverse the bucket array. To traverse the bucket array, we need to go from 0 all the way till our range, because the bucket array will be the size of our range. So let's go for I starts at 0 and I ends at n minus 1. Now, what will we do? We have to empty out each of these indexes. So, while the bucket of I is not empty, then we will first take out the element from the bucket of I. So we will take it out and store it in some object. So an object which has a key element pair is going to be B of I, and I want to remove that. Remove first. Now once I have removed that element, I will add this element to the end of our sequence. Note that over here our sequence has become empty. So now we can start adding these elements back into the sequence which has become empty. So we say that s dot add to the end or add last of object. And with that we come to the end of phase 2, because we are going to do this for all the buckets. So let's see how this works. I is 0 to n minus 1. So at 0, while B of I is not empty, B of I is empty here because B of 0 is empty. So we go to the next iteration. I is 1. While B of 1 is not empty, B of 1 is not empty. So we store 1 comma C in a variable object. Then we add 1 comma C to the end of our sequence. Once we remove 1 comma C, when we remove first, 1 is going to become empty. Then we say while B of I is not empty, but at this point after having removed 1 comma C, 1 is going to be empty. So we go to the next one. 2 is empty, so we go to the next index. Then we see 3. 3 is not empty, so we go to the list 3. We remove the first element. We remove 3 of A. Then we add it to the end of the list S. Now when we remove 3A, we go and check whether B of 3 is empty. B of 3 is still not empty because 3 comma B is still there. So 3 comma B still exists. So we remove this from that and we add it to the end. Now B of 3 has become empty and we go to the next one. This is how you keep going through the different indexes and create the sequence once again. So this is how bucket sort works, and this is the algorithm for it. This is going to be phase 2. And with this we can return our sequence and we come to the end of our function. So let's see how much time each of these phases take. So phase 1 is going to be order of what? It's going to happen for all elements of S. So what are the number of elements of S? Let's say the number of elements in our sequence is n. Now let's see phase 2. Phase 2 will occur how many times? It will occur n times, which is the number of elements in our range. So phase 2 is going to be order of capital N. So this is going to be number of elements or number of tuples, and phase 2 is going to be our range. So totally the bucket sort is going to take how much time? It's going to take the first phase time plus the time taken for the second phase, which is small n plus capital N, or number of tuples plus the range in which we are going to sort. So this is bucket sort. This is how we write the algorithm for it, and this is how you can determine the big O of bucket sort.